7 aircraft, a ship, hundreds of scientists from all around the world, and just 7 weeks to do the job.
It's also a sanity check. I'd like you to look out the right window
and see how close you are to the storm.
They call it ICE, the International Cloud Experiment. Their mission, to catch a cloud. But not just any cloud. They want to catch a thunderstorm. Australia's city of the top end, Darwin. Here, the wet season is an opportunity to catch the perfect storm. Darwin is a breeding ground of tropical monsters. Thunderheads.
For a guy who studies storms, Darwin is like a big sandbox to play in, and I'm here to play.
The thunderstorm even has a name.
Hector. It's the monster of all thunderstorms, and apparently is found very often here in the Melville Island area. A very, very large storm, very tall. You know, we do think of Hector as the beast. He is supposed to be one of the largest thunderstorms known on the planet.
He packs more energy than 10 nuclear explosions. The sheer size and power of Hector, plus his dependability, have brought the ice team to town. Their specialised planes arrive from Russia, Germany, Australia, the UK, and the US. The experiment brings together some of the best pilots in the world. Alf Jonas in the Egret, ex-test pilot and Air Force squadron leader, who in 1997 helped coordinate the rescue of Tony Bullimore. The Russian geophysiker will be flown by 2 Russian pilots, Oleg and Oleg. Oleg Sr. is a living, breathing hero of Russia, decorated for his services to atmospheric research. Englishman Carl Joseph, who crashed into a Scottish mountain, broke his leg and walked down to tell the tale. He'll pilot the Dornier. Mike and Brian, flying the Proteus, are in fact astronauts, already famous for having flown the world's first privately funded space mission. Indeed, getting into outer space seems to have been less of a challenge than getting to Darwin.
You can just start it up in the hangar and drive out.
Crossing the Gulf of Carpentaria, they encountered a thunderstorm phenomenon that few people have ever experienced before.
We're pretty high, 48,000 feet, which normally puts you above most of the weather we're familiar with, and we're kind of cruising along pretty comfortable, and literally the nose of the airplane drops out from under us.
We flat didn't understand what was going on.
We're starting to fight the airplane to try and get it back up. That lasted about a minute, and we got out of that, and before we could think of anything really smart to do, we got into another one.
Most disturbingly, Mike and Brian were in clear air.
That was turbulence like I've never seen before.
It seems the Proteus hit a so-called gravity wave, a massive atmospheric tremor sometimes caused by a collapsing thunderstorm.
We had never heard of the gravity waves before. I thought that was some science fiction thing.
Well, I'd never heard of gravity wave either. It was obviously something significant, and it obviously scared the shit out of those guys.
The atmosphere is still a frontier, a giant jigsaw puzzle, with most of the pieces still missing. The critical missing piece: clouds.
Clouds are the single most uncertain factor in trying to understand our current climate, much less predict future climate.
Climate change is no longer a theory. It has begun.
We're living in an era of global change. Temperatures have been rising steadily since the 60s. What are we going to leave for our kids in 100 years' time? It could be a different world.
Clouds trap heat and reflect sunlight back into space. As the Earth heats up, will the planet's cloud cover change? Scientists simply don't know. But part of the answer must lie in thunderstorms, because thunderheads are the clouds that make other clouds. The ice scientists don't know precisely what findings await them, but making sure that the huge experiment is heading in the right direction are three men in mission control. Geraint from the UK, Dave and Ed from the US.
Or it didn't make that scan.
So what's it like to be in charge of this huge undertaking?
As 95% boring and 5% stark terror. One wrong move and we could be sending an airplane into a dangerous location. We all need to sort of understand how to push each other's buttons properly.
With limited time and money, ice hits the ground running. So all systems go, when suddenly a thunderstorm sidles into town. Heading straight for the airport.
If they didn't like what they're seeing as they taxi, they might have mentioned it.
Yeah, so it's not raining. So that red area is going to go to the top of the screen.
Probably right over the top of the airport. It would be a very good idea to get off the ground now.
They can get off if they go ahead and do it.
Yeah.
If we have a thunderstorm approaching an airfield, if it's within 5 miles, down tools, you're not going anywhere. We're not going to take off in this condition.
The pilots return to the hangars.
Very few of our airplanes like to get their instruments wet, and that's a bit of a contradiction. We're here to study rainstorms and thunderstorms, and yet we don't want the instruments to get wet.
Well, they can get wet at the end of the mission. They don't want it. If they get wet on the way out, then they don't work so well.
Yeah, I just wanted to let you know that there's a possible severe thunderstorm approaching Darwin Airport.
There we were, all ready to go, sitting on the ground waiting to fly, and in comes this massive thunderstorm saying, "Hey, you're not going to come out and study me, I'm going to come in and study you."
She sort of brought home the sort of instability of the weather in this region.
You know, if we knew what was going to happen in advance, we probably wouldn't need to be here. So it's always a big mystery, and that's what really makes this research really fun, because we don't know what we're going to get.
What they do have to get are measurements, data.
It takes a lot of money to do this. A lot of huge effort went into making this happen, getting all these instruments ready on the planes, getting the planes over here.
Mission Control cannot afford to waste resources on missions that don't deliver results. But it's not long before there's something new to spend their money on.
So it is getting nasty looking out there.
Quite a spectacular build-up right happening behind me there, and we heard from the people at the Bureau of Meteorology that the tops reach up to 20 kilometers.
Yes, there's a sense of excitement, a sense of anticipation. All the scientists have worked for 3 days straight to put all the equipment together, and this is the actual first event that we've got, and we're finally getting airborne.
Today, 4 planes will tackle Hector, the English Dornier and German Falcon from below, the Russian Geophysica and Australian Egret from above. Mission scientist or team leader will be Garant.
Let's go fly some airplanes here. New coordinates there in about 5 minutes.
It's off to the north, to Hector's lair. Here, the virtual net has already been sprung. In a 150-kilometre circle around Darwin, weather balloons are released every 3 hours. The ship completes the ring. Transmitters carried by the balloons will send back a record of the atmosphere in which every Hector is born, grows, and dies. The planes now maneuver within the net, moving closer. Each high flyer has a corresponding low flyer. Flying point for Alf and the Egret is low flyer Carl and the Dornier. Carl will sample what is being sucked into the storm at the bottom, while Alf will measure what is being spewed out at the top.
The business of tropical thunderstorms, the way they work, is they take air that's very low near the ground and take it in one big gulp and put it up in the stratosphere.
When we actually saw a superb example of Hector, I could see some sense in what the scientists were trying to do.
"12 kilometres above Carl, Alf gets into position.
My job is to fly through the anvil at the very, very top of the thunderstorm.
The anvil, so-called cirrus cloud, is the very top of the storm, blown sideways by high-altitude winds. This one is more than 100 kilometres long.
About 1240, I think you said. Now,
It's this part of the storm that Alf has been asked to fly through.
just last comment.
Okay, Alpha, I'll put it another way. Fly 30 miles along your reciprocal track and call us. Over.
Under no circumstances must he stray into the dangerous core of the thunderstorm. Radar on the Dornier will guide Alf, close to the core, but certainly not into it.
The concept of getting too close to the main active part of the thunderstorm is a little bit off-putting. There's lightning, there's icing, severe turbulence.
Well, if you were stupid enough to fly into the core of one of these huge thunderstorms, then the plane would probably be destroyed.
Into the anvil he goes.
Flying through the anvil, I could not see, past my wingtips basically.
Although twice as tall as Mount Everest, Hector is not stationary. He moves sideways, fast. And the anvil is downwind. 6 kilometers above Alf, the Russian Geophysica prepares to fly over the top of the storm, guided by the Germans in the Falcon.
Their focus is very much on transport of material into the stratosphere. The ozone hole is in the stratosphere. There are high concentrations of ozone apparently coming out of these storms. And we don't know why, we don't know what's happening there. The Geophysica can get into this part of the atmosphere, which is almost inaccessible to any other aircraft.
The Russians have been asked to skim the very top of the thunderstorm.
Того, что эта облачность очень страшная. Когда сверкают молнии, в принципе, их видно только ночью.
Because the Geophysica flies so high, its low-flying support plane, the Falcon, actually has to fly quite high itself. As Alf and the Egret descends, these two aircraft suddenly find themselves only 1,000 feet apart in altitude.
Time to go as far as they can, such that when they need to turn around and come home, they can get home.
Absolutely. The point is that this is showing some really...
In all the excitement, Mission Control suddenly becomes aware of the problem.
Point out here.
They'd like to get as far as they can on that track.
And believe me, when the airplane calls back and essentially tells us that he's in the wrong place, there's a lot of quick scrambling to figure out how to make that right.
Why not the hell go up here?
To go from this point to this point. And he actually went west. And because he hits...
The planes pass one another without incident. Returning to base, Alf has time to take in the view.
I've actually looked underneath that anvil and I've seen that the whole thunderstorm stack, as huge as it was, is just collapsing. The whole thing just collapses. It's incredible to see.
Alf's mission has been successful, but he thinks instructions from Mission Control could be improved.
Oh golly, there's rough weather out there. These guys are supposed to be looking after us.
He intends to raise his concerns and finds Garant has a different spin on what happened.
You shouldn't have been below 38.
Shouldn't have been below 38.
No, because the Falcon was
I thought you said 5 or 200 for him.
I mean, Falcon was a long way away at that time, but it came and...
That does ring bells. I personally know 22 people, friends of mine, that have died in the pursuit of aviation. No bones about it. It's a dangerous thing to do.
What things should you change so that the thing that didn't go real well today will work out well next time? By the end of one of these things, we're doing a pretty good job. We've learned a lot of lessons.
There is another way to get data from very high altitudes, as shown by balloon scientists Terry Deschler and Jenny Mercer.
42? What did it start at? Where'd it go?
To get to the stratosphere, there's only a few ways you can get to the stratosphere. High altitude aircraft only get to the lower stratosphere, and the part that we're interested in is above that, so you can either use rockets or balloons. So we use balloons.
Anthony, you're on. I need you. 242?
And so the balloon is released on the count of 3.
3! Let go. 5.
Terry notifies air traffic control of this additional hazard for aircraft.
So anyway, I just wanted to tell you that we're off the ground and we're underway.
Pilot south of Darwin, please be aware there's a balloon currently ascending about 10,000 feet and rising. I believe it's silver in colour. Stop it all, actually, you get that in. Shut.
Oleg has his brakes cooled, Russian style.
It seems a bit strange. I mean, they could just shatter with with a sudden cooling. But obviously, somebody somewhere must have checked this out. And
конечно, работа приносит большое удовольствие. Особенно это ощущаешь после того, как произведешь посадку. Полеты, в принципе, довольно трудные, то есть получаешь моральное удовлетворение именно после того, как задание выполнено.
You're successfully climbing, that's correct?
Terry's balloon is now well out of the reach of aircraft, more than 30 kilometers up.
We're all clear with air traffic control.
Around 33, 34 kilometers, we send a command, and then the balloon breaks. The instruments then are parachuted back down to the ground.
We're separated.
But as the instruments descend, wind pushes them towards an army artillery range.
Is there any problem with unexploded ordnance?
No worries, mate. You go for it.
Because we don't want to step on a bomb.
Right.
Not interested.
During the night, Terry and Jenny analyze preliminary data from the balloon, revealing extremely high amounts of tiny particles such as dust and ice floating very high in the atmosphere. perhaps left there by a thunderstorm. This kind of data really excites the people of ice. In fact, little excites them more than ice itself.
The main thing that I am interested in is getting more information about the numbers, the sizes, and shapes of the ice crystals that are in the cirrus clouds that are generated by thunderstorms.
A thunderstorm pushes so high that the moisture coming out of its anvil is snap frozen. These wispy cirrus, or ice clouds, live on well after the thunderstorms themselves have died. As the Earth's battle with the sun heats up, these ice clouds are at the front line. Enter Proteus, the ice specialist. With the twin otter flying in support, the Proteus heads out to grab some ice.
Ascent.
Today, Dave Starr will run the show.
Ascent. Climb.
It's off to measure microscopic ice crystals floating 15 kilometers up in the sky.
Try and think about a plane that's maybe traveling at about 130 meters per second and trying to measure the size of an ice crystal that's only 1/100th of a millimeter. So we need very sophisticated instrumentation in order to do those type of measurements.
Mounted on the wing, a laser-guided micro camera. The size of ice crystals in cirrus clouds has a critical impact on the Earth's climate.
The warming cloud versus the cooling cloud. There are two ways that cirrus clouds affect the climate, and they're both extremely important.
Ice clouds made up of large crystals tend to let in more heat than they reflect, so they act as a kind of earth blanket. Ice clouds made up of small crystals tend to reflect more heat, thus creating a kind of shield effect. The ice scientists are keen to understand why a thunderstorm produces big crystals or little ones. So they've asked gravity wave survivors Mike and Brian to film the ice crystals coming fresh out of the thunderstorm, right near the core.
We rely on the scientists to keep us away from that. They very well understand the dangers of getting into something like Hector.
We don't want to spook them.
They try to get us close enough to see the cirrus, to look at the ice crystals coming off on the outflow, but they don't want to put us into any kind of jeopardy.
Back on the ground, unexploded ordnance will not deter Terry and Jenny from getting their data.
Tally ho! Hey, Miles.
In this direction is what I would think. Possibly that way.
That way.
That way?
Oh, no.
This way?
That way.
The other places where we do this, we'd be recovering on an ice shelf in Antarctica, so it'd be a flat, big piece of ice.
It's that way.
This way, if we gotta take a look.
No, not that way. This way.
Well, I just said this way.
We finally decided that with the heat we had to give up for the day. It's not just over the hill, obviously.
It could be a fair bit further.
Yeah.
Mike and Brian also find more than they bargained for.
But I'll tell you, the top of a building thunderstorm is something to see. It is a horrifying sight.
Our plan is to keep you flying
This line as long as possible.
Proteus is not going to want to go too close.
We want the pilots to be confident that we know what we're doing. The minute we tell a pilot to head in a direction that he thinks is unsafe,
Oh no, sorry, your Q is 1,000.4.
that means he's going to have a lot less confidence in the guidance he's getting from that control room.
Yeah, you may want to put the hammer down. There's something...
We do try to do everything they ask us to do. In the real world, if it's not good, we're going to turn around and leave. Boy, I was very glad to get away from the top of that storm. That was a scary thing to look at.
I don't know
Mission Control has trouble raising Proteus on the radio.
Somehow we're losing this link. Proteus, iSpace.
The Proteus and the Control just were not on the same page right from the get-go, and that was a bit stressful.
Poor guy. Is it my breath?
When we make a decision, that's what it's going to be. The scientists are going to have no say in it. If we don't like the situation, we're going to turn around and come out of it.
Proteus, iSpace.
We've chased weather before, but we've usually been located at a place that's separate from where the storms are, so we can get in and out of the airfield.
Proteus, iSpace.
Here we are descending through clouds, trying to avoid the flashing purple stuff. We have our weather radar that gives us a colographics of what's going on in front of the airplane.
Flashing purple is your worst nightmare.
Roger.
1 week in, and already behind schedule. Mission Control worry about safety, but equally about time and money.
Yes. Go ahead, JPL.
I can barely read
You know,
you.
it's very expensive to do this, to fly these planes around, so you don't want to waste time screwing around.
The experiment pushes bravely onwards, and then the Egret's propeller goes down. Having provided the aircraft to the experiment, pilot Jorg is accountable.
We have now spare parts being shipped to us here from the US and from Germany, in fact.
This problem with the propeller of the Egret is by far the most serious problem we've encountered, because of course it grounds one of our aircraft, and for a week, which is a significant amount of time. You know, we have limited time here in Darwin. Look as though it didn't work.
Tension between pilots and scientists is mounting.
Excellent.
The data hasn't been supplied.
No data.
You don't know. You don't know, or there is no data?
No data, no data.
People who are relatively new in this, they come up with sophisticated plans, and we have to do this, plan it all in advance to the last issue. I think this is one of the problems. In a way, we are trying to do big science, because this is what this experiment is, with extremely limited resources. And I think we might have gone a bit too far. The Geophysica has, from what I was told, 20 people to just look after the aeroplane alone.
The Geophysica's got a team of about 25 engineers. For the Egret, we've got one guy, and his name's Rudy, and he does the work of, well, 25, I suppose is the way to look at it.
The linchpin of the Russian team is 75-year-old Misha.
А без отвертки ключа ничего не сделаешь.
Boys will compare toys.
It's typical Russian technology, you know, it's sort of built like a brick outhouse.
Now we're talking, bro. Here we go. All four of us were walking along this wing and the thing didn't budge. Carl and I had a good sticky beak into the cockpit, and we reckon we could have possibly taken off if we had to put our heads together, but there wouldn't have been room for Carl and myself in there. All right, well, thank you very much.
Terry and Jenny would simply be happy to find their gadgets.
Stop here at this intersection.
Yep.
This is our track.
Okay.
And then we've got to make this corner here.
Okay.
This is where we're headed. That's no problem.
The Egret has gone down, but the experiment must move forward. The Russians and Germans fire up for action. Occasionally, a veil-like cloud forms near the top of a thunderstorm. Known as the cap, it indicates extreme updrafts and is particularly dangerous for aircraft in terms of icing. So the scientists have asked the Russians to fly through it.
You can go back in time.
Yeah, there is a 164 pixel on that sucker.
Yeah, you can see the blister on the top of it there.
Я сейчас начинаю мой полет.
В общем-то, мы стараемся пройти над этой шапкой в том случае, если она не очень высока. Как правило, эта шапка исчезает. То есть это настолько скоротечное явление в гекторе, что его, видимо, поэтому-то и плохо изучили.
Сейчас пролетаю. Пролетел.
How useful the data collected will be remains to be seen, but the ability to get it in the first place is certainly appreciated.
То есть ученые есть ученые. Они, конечно, мыслят немножко по-другому. Но им всегда хочется, чтобы еще пониже и коснуться чего-нибудь.
You can see water a long way. Okay. We can get through that.
We're going 2 miles an hour. Just on the area of the no-go area.
So all instruments stayed on, which is great, because there's always a danger when we have the impact that something falls off because of such a shock. So it was great. Found our instruments and very pleased about that. Very pleased to find that there's no damage.
Above, the action continues. The Falcon is specially equipped to study lightning, which as dusk falls, goes off.
Can we try to intersect the middle section of this? Yes, yes.
Werden wir zum Meer an. Ich möchte lieber nach Hause umdrehen.
This needs very experienced pilots to do flights like this because we are coming very close to the active part of the thundercloud. And of course, we have to wear our safety belt. There's quite a turbulence then in the aircraft. I feel pretty safe, I must say. There was a small lightning stroke which hit the meteorological boom. You know, we have this meteorological boom. There was a faint lightning stroke which was impacting on this boom.
Lightning is, of course, what defines a thunderstorm in many ways, and we try not to get our plane struck by lightning because the instruments are expensive.
Of course, some checks have been made, but that was not a big lightning stroke.
The Falcon and Egret are both down, so York prepares for new thrills in the tiny Demona.
He flies this thing at about 20 meters over the ocean and over the treetops, and he does this so that we can measure how much water is evaporating from the ocean or from the land surface.
This is one of the driving forces of Hector. How does this thing start?
York's mission is to try and measure evaporation as close to the source as possible.
All right, that's a life raft.
One of the requirements for York is to stay constantly vigilant, because less than 100 feet off the ground, you don't have a lot of time to correct for oopses.
Directing York from Mission Control is Ed.
As long as the wind's blowing this way, we're not messed up here.
The ship measures many of these things continuously at one location, but that only gives you the information at one location. What you do want is you want the information over an area like many square kilometers. The only way to do that is you use an aircraft and fly over this area.
How far offshore do we want him to go?
How far is he comfortable?
No, how far are you comfortable going out?
Jorg is persuaded to fly 70 kilometres out to sea, correlating his measurements with those of the ship. That done, he can return. The evaporation data gathered over the ocean is valuable, but the real surprise comes over the land.
The air was chock full of smoke particles. This surprised us, but it also means that we have something very important to put into our models, because we're very interested in seeing what the effect of these particles have on the storm itself.
Particulate matter floating in the air is an essential ingredient to help seed a cloud.
One of the things we're starting to appreciate is that heavily polluted air masses, especially polluted with smoke from fires, biomass burning, the thunderstorms appear to be stronger.
One of the theories is that if you have very polluted air, then it helps the storm develop. I mean, it's contentious what I've just said, but these are some of the theories that we're pursuing in this project.
With pollution on the rise, what might be in store in terms of future storms?
Clean air versus dirty air thunderstorms. The thunderstorms that are forming in air polluted with forest fire smoke do appear to be stronger and have more lightning in them than storms that don't, and we're trying to understand that.
I can't do it with a cold drink now. You can see all the bugs on the wing. That's a good sign that I flew low all the time over land.
It gets better. Jorg's propeller parts have arrived.
My wife brought the parts with her from Adelaide. She had to take them through securities. It took her quite a while to explain to them what it is. And I mean, she doesn't look like somebody who is dealing with aeroplanes. So.
Rudy said, here's the aeroplane, Alf, you go fly it, and it should be fixed now.
The egret is put back together. But making sure that it's airworthy keeps a pilot on his toes.
When I look at the egret and the Geophysica, I sometimes worry how the pilot can keep control.
As my final walk around, I have just been very meticulous in every little oil drop, every little screw, every item that I can think of. When I sweep around, it's with an eagle eye. I did, before flight, realise that there's a couple of screws that haven't been done up.
That one rattling around, the locks, that's the locks one.
Yeah. Ultimately, the responsibility lies with me as the aircraft captain for ultimate aircraft safety.
Soon after takeoff, Alf has a problem. His airspeed indicator begins dropping.
And I put the power up and I was trying to level off and it just wasn't adding up. And then finally my airspeed indicator read 0. If you lose airspeed, obviously all bets are off. You don't know, really seat of the pants, what you're doing. I actually declared a pan.
And really what it means is I have a serious problem and I need to land immediately.
The only problem we had was that as we turned around, there was a thunderstorm looming over the active runway. And I looked at the opposite runway and I just flew the aeroplane down as quickly as I could.
Dodge thunderstorms, dodge lightning. I'm sure he was sweating a little bit. we saw the hatch open, and the pilot sort of just sat in the cockpit for some minutes, just collecting his thoughts.
So, I did wonder, of course, Mr. Hacker, what was the cause of it. My initial thought was, and it was quite correct, was that in the process of fitting scientific equipment, somehow the pitot-static system had been disturbed. Yeah, I had a bit of time for reflection, thinking, that wasn't as great a moment as I would have preferred.
This, there's no question, is by far the most difficult experiment I've done during all my life.
Mysteriously, on the same day, the same thing happens on the Geophysica. How can such a rare mishap occur twice the same day?
It could have been the same thing that happened to me. Science activity in the rear of the aircraft knocked the pitot-static system. I don't know what happened, but it is a bit odd that both of us experienced that. I'll have to chat to one of the Russian pilots about that.
The problems are fixed, and everyone is asked to take greater care pulling the planes apart. It all costs time, though. Soon there's a push to fly missions back to back.
I don't want to be rushed.
Okay, good. Thank you very much.
For the next few days, we are planning to fly every day. It's difficult, but that's what we are trying at the moment, because we have to catch up on time that we lost.
Following the near disasters, does Rudy, the egret's lone engineer, worry about the added pressure?
So far, I haven't heard anything bad.
The Russians continue into the night.
Oleg's actually on his own. He doesn't even have a mission scientist to help direct things.
Это тоже в какой-то степени доставляет удовольствие, что успеваешь налетаться вдоволь. Полеты ночью хорошо видны звезды. И получается, что гораздо, кажется, ближе звезды и Луна.
Some worry that things may be moving too fast.
You know, this looks nice and beaut in the briefing room and a clear map, but I can't see the ground. So these are critical points so that I know where to escape to.
Absolutely nailed the tops of the Cirrus dam that we've been working on.
But the hectic schedule pays off. Alf returns from a close encounter with the biggest hector of the experiment.
It was very successful. We relied on these guys telling us exactly where the core of the thunderstorm was. Kept going, trusted them all the way. You owe me a beer. We survived and came back. It was good flight, very successful.
I believe we are back on track.
Be optimistic now.
The Proteus takes off for a closer look at what remains of the monster Hector. What it captures inside the cirrus clouds delights the scientists.
One of the things we've been trying to do is we've been trying to track an ice cloud and how it evolves over the course of time.
There's kind of a viewpoint that people have that a lot of the cirrus clouds are dead material, that these clouds are just pumped out and they just kind of passively go away and kind of waste away.
The data from the Proteus suggests otherwise.
As you go away from a storm, instead of just seeing decay of what it started with, you start to see the cloud remaking itself. And you can see that in the crystal habits. If it's regenerating, you'll see beautiful rosettes.
But what does it mean in terms of the big versus small ice crystal puzzle? The ice scientists simply don't know, but they're nevertheless thrilled with this new, unexpected data.
I'm really impressed that they did such a good job.
Actual animations of what I did, Peter.
Dave and Greg are so pleased that they're eager to get back to their computers at home.
Yes.
Most people get the data that they need, and then we go back and analyze our data.
The Cirrus guys don't know what they're talking about if they say they can go home now. They can go home now because they've got enough new stuff to look at that they can write a bunch of papers. I can't go home now, and I don't think they should either.
Averaged it out.
Ed would like to see one last big, ugly storm. And amazingly, he gets it. Right in the middle of the net, something big is brewing. A series of thunderstorms pops up, one after the other, and then together start rotating. For the very first time, scientists precisely capture the birth of a cyclone.
They do this.
We got a lot of soccer.
So what else is there?
Curiously, the severe tropical low heads inland and keeps building. The Dornier scrambles for one last almighty storm chase. Carl's team should be able to both catch the storm and return.
He's going to fly on there's a point October.
A strong headwind.
The Dornier has not failed once whilst we've been out here. The serviceability rate has been fantastic. So it's a new dimension, so it's interesting.
The scientists nicknamed the strange phenomenon Landfoon John. Cyclones are normally creatures of the ocean. Without moisture, they tend to shrivel up and die. Landfoon John is now 2,000 kilometres inland, stamping across the Tanami Desert. What on earth is going on inside this strange storm? Is it a rare but normal phenomenon? Or is it a glimpse of the kind of thing in store for an even warmer planet? A future in which cyclones will be untamed by deserts. A future in which thunderstorms become even more common and wild. The ice team is happy. In minute detail, they have captured the birth of a cyclone. And now the Dornier brings back new data that may reveal what was going on in the heart of this bizarre desert event. The icing on the cake.
This probably is what is called a golden day.
So I think everything they expected was there.
Talking about this all over the world among tropical meteorology experts, trying to figure out what is this thing and why did it persist that long.
The ice experiment is over. So what's the outcome? Will clouds be our salvation or our doom?
This is a 4-month field program, and then after that we have 3 years of analysis and theory.
And you've got a 500-piece puzzle. And even with all the aircraft and all the ground-based measurements we have, we still only have about 16 pieces of the puzzle.
no one's come up with any other bright ideas for a better way to look into the future. I think we've made a lot of progress, but I still think we have a long way to go.
The pilots seem to be happy to be going home, alive.
It's called aviation risk management. Stay alive to fly another day.
Pretty adventurous for a couple of guys that had thought, this was
going to be a vacation.
Pretty straightforward. Yeah.
Yeah, it hasn't been.
Скоро мы уже будем, к сожалению, наверное, покидать и Дарвин, и Австралию. Но она у нас останется в сердце.
And back to old Blighty. I've got an 18-month-old daughter who's forgotten what I look like. I'm definitely looking forward to go home.
Please ensure your seatbelts are firmly fastened. Our resident thunderstorm Hector has dropped in unannounced.